So I'm Mike. Hi, everybody. I'm currently the owner-operator of Spancy Music and Sound, which is an independent audio production house based out of Seattle. Prior to doing my own thing this year, opening my own shop, I worked at Microsoft for a long time, where I was first a sound designer and then an audio lead at Turn 10, where I made the Forza Motorsport series of games for a really long time. And then I went from there to be kind of the overall audio production director for Microsoft Studios, where we touched just about everything that Microsoft Studios published first party. I've got quite a bit of experience in the racing genre, and I've had the good fortune to be able to kind of look, under the hood, if you will, of a lot of different games and see some different types of implementation systems and just sort of vehicle design concepts. So I figured, I'd share some of that stuff with you today. We'll be talking about, creative approaches, some recording technique stuff, some implementation design, system design, that sort of thing. So, and this is a half-hour talk, so I'm going to be jogging through a lot of the material. I know some of you in the room know what that feels like. All right, so let's start here. This is in thinking about vehicles from kind of a high-level, like game designer standpoint almost. And nearly every vehicle I've worked on has featured these 5 basic sensations that the designer is trying to get across. I'm going faster, I'm going slower, I'm changing direction, I'm giving it, input. I've lost control, or I'm losing control, and audio is actually a very big part of that. And then I'm stopped. What does my vehicle sound like when I'm stopped? And ultimately what we're trying to do is to get the trick with these is that we're trying to get the player to feel these sensations without the benefit of physical feedback, which, so audio obviously is going to play a huge part in getting these sensations to translate. Nearly everybody on Earth at this point has been in some sort of powered vehicle, so everybody has some sort of own personal reference point as to what it feels like to go faster or slower, so they all know what these sensations are. As an example, a race car driver knows where the edge of their traction is, knows where the edge of their grip is in their car by feeling G-force. They turn hard, they feel the G-force sort of push you in your seat. And then if you keep turning, the race car driver knows that sort of the scary part of the experience is when you're turning and you feel that G-force and you're still turning and then you feel that G-force get a little less, even though you haven't changed how much you're turning, and that means you are starting to lose control. You're drifting, and things are going to end very, very badly for you. So using audio and haptic feedback in particular. We'll talk about tire sounds as sort of an example of that. But audio is a big part in getting these sensations to translate. And then, to help kind of realize those sensations we just talked about on the last slide, I've kind of, here are the 3 elements that I've found that basically kind of make up the vehicle experience from an audio standpoint. You've got your engine sound, your power generation stuff, surface sounds, behavior of your vehicle as it kind of either makes contact with ground, or if you're in a ship, this is the sound of your vehicle moving through space or air or whatever it's moving through. And then what I like to call the violence layer, which is making going fast feel like going fast. The engine sound is kind of the core sound of the vehicle, so this is the part that you really want to get right. This is the thing that people are going to remember when they get out of the vehicle, so this is what I usually like to concentrate or prioritize as the highest priority. When somebody gets out of the vehicle, this is what they're going to talk about when somebody asks them, hey, what did that car sound like, or what did that ship sound like? That's what they're going to be talking about most of the time. Surface sounds would be, tires if you're in a ground-based vehicle, but if you're in a plane or a spaceship, this is the sound of your vehicle traveling through airspace. This could be the sound of, wind buffeting around. If you're in a plane, it could be the rumble of, your ship's chassis as it pulls G-force. Maybe you have different sounds rumble, maybe higher pitch rumble for lateral G's, which are, moving side to side. And then maybe you have a different type of rumble sound that plays, going from forward to back as you pull front to back G's as you speed up or slow down. And then the violence layer. This is basically making, going fast feel fast. Going fast should feel rough, probably even a little scary. Think about going fast in a straight line. What makes that feel fast? Usually it's stuff like road noise, chassis shake, wind noise, it's Doppler, it's the stuff of things rushing by you at a high speed. Just even the basic example of something going zoom versus shoo, implies some sort of sense of speed. So even invisible objects, you can kind of fake the sense of speed with by doing that sort of thing. But this could also be things like, the sound of engine strain at top speed, at your top RPM, making it sound like, you want your engine to be like, oh God, please shift me before I destroy myself. It could be the sound of debris that happens. Think about the kinds of things that make, going fast feel fast. What are the visceral parts of that? And then, so these are the sort of 5, for me anyway, these are like the 5 core physics inputs that I always think of that will kind of control the 3 experience components that were on the previous slide. Keep in mind not all these systems might be used by your game, but chances are there's at least probably 2 of these. Nearly every vehicle in the world needs to at least go and stop. If you're making a game for an iPad that's a single touch button, you still have go when my finger's down and stop when my finger's off it. Keep in mind that, for even a game like Forza's system, for its engine anyway, used primarily throttle and RPM. That was about it. Everything else kind of controlled other systems, but for the engine, it was primarily throttle and RPM. So there's a lot you can do with just a few very basics, few very basic parameters that you can control anyway. Keep in mind that some vehicles might be binary, some might be gradient. Controllers have both triggers and buttons, so figure out how your vehicle is going to be controlled. Is it going to be the button on-off type thing, or am I going to be able to sort of gradually apply throttle via a trigger? And there's a lot more game and physics parameters that could be used by the audio system than just these, and we'll see some a little bit later. But these are kind of the basic building blocks of an engine system. And then just as a real quick picture of, these are just some of the ideas for people who've worked in racing games before. This is nothing new, but for people who maybe haven't been exposed to racing games, these are some of the basic systems that are kind of out there right now. And these are important to think about at a very high level because this will affect how you go out and you record source for these systems. You have loop-based systems, which are basically you think of it like a musical instrument sample set where you've got, sustained loops that you're cross-fading between. And you can do this at any number of states, any number of throttle states. Are you going to record your car full throttle and then half throttle and then quarter throttle? How much do you really need? For Forza, we would record our cars every 500 RPM at full throttle, and then we would use in-game DSP to kind of help model the various throttle states. Then you have granular systems, which are things like, if you've used Wise, like, the Rev system, which basically they have a source recording of a car doing a power run, which is kind of idle through redline, full throttle, just and then you'll take that recording, and then a lot of granular systems will pitch flatten that recording, so you end up with they'll take that recording and make it one pitch so that you have a timbre change but not a pitch change. So it's that kind of thing. And then they'll use that as source to generate grains out of. They'll take little firing cycles from various parts of that and map that to the RPM range of a vehicle. And then this one here is kind of the future synthetic systems where you use you make a recording, but you use it as reference only, and you can do analysis of it. And what if you had, given, the power of modern consoles, what if you had 160 oscillators in your game, that could all help you synthesize engine sounds, and that we're all working on the fly. So it's a purely synthetic model, and some teams, I should say, are actually exploring using that. So, I usually like to try and understand how an engine works, or more importantly, I don't need to have mechanic level knowledge of how an engine works, but I need to know what the primary noise-making components of an engine system are in order for me to either A, record it, or B, implement it. So I'd like to kind of understand the signal flow of an engine, whether it's a real-world engine or an imaginary engine. For a real-world vehicle, what, like the slide says here, what mechanically makes your machine move, and more importantly, what are the sound generation parts of that process? For future vehicles, this is up to you, actually. How it works is maybe something you, as an audio guy, you could just sort of imagine how it works. I mean, the control of it's going to be up to the game designers, but maybe your future engine, think of it in terms of, think of it out of the box, actually, a little bit. Think of it like, maybe my engine is based off of something spinning. Maybe it's laser driven. Maybe my engine is based off of magnetic fields. Maybe my engine runs off of magic ethereal gases. One of the ones we had one time was, what if your engine actually works like Cyclops from the X-Men, where his eyes are making power, full power, all the time, and he just lets that power out in bursts with his visor? What if you had an engine that worked like that, and you could just sort of eke that? What if your engine's making full power all the time, but you've actually got it shut off most of the time? You just sort of let it out in little bits. And then I like to ask myself, sort of high-level, interesting design questions that are kind of based on that sort of thing, like, size versus fuel type versus, vibe, for lack of a better term. What if I have, I want a small, angry, fuel cell-driven vehicle? Or what if I want, like, a cute but stealthy, gravity well-driven vehicle? Think these, kind of out of the box, sort of, briny, oblique strategy type things, for thinking about vehicle sound design. All right. So, we're kind of divided up into, real world engines and imaginary engines. And for real world, I want to talk about real world engines for a minute, because these show up in a ton of games. And the most popular real-world engine in the world is the internal combustion engine, the four-stroke. I should be a little more specific. The four-stroke internal combustion engine, which shows up in just about every gas-powered vehicle on the planet. In the previous slide, talked about understanding the signal flow of a vehicle, and here, in a nutshell, is basically how an engine works. Sorry if this is a little gear-heady, but it always helps me think about it. Air comes into an engine. An engine sucks air in, and that air gets combined with fuel via a fuel injector or a carburetor. And then you have and then you have that air-gas mixture. That goes into a cylinder where it gets compressed by a piston and then blown up by a spark plug. And then what's left after that explosion goes on out your exhaust pipe. So when they say a four-stroke engine, that's what they mean. They mean stroke one is when the piston in the cylinder comes down and it sucks in the fuel air mixture. And then stroke two is compression, where it pushes up to the top of the cylinder and it compresses it and makes that mixture very volatile. And then stroke three is the power stroke, where the spark plug lights off at the top of the cylinder and boom, blows that mixture up, which drives that piston down, and that's the power stroke. And then you have the exhaust stroke, where the piston comes back up and pushes all those unspent gases out down the exhaust pipe. So that's a four-stroke engine, where you have intake, compression, power, and exhaust. And what we care about out of this, in terms of the sound components of this process, there's some things that weren't necessarily obvious to me before I started making racing games about how an engine made sound. And a big one is actually the induction note. So the induction note is the sound of air rushing into the engine. This is actually a primary sonic characteristic of a lot of engines. And we usually mic this up. This is an actual tube. This is, and you'll see a picture of it here in a minute. This is an actual tube that routes air from the atmosphere right into the engine, or right into the intake plenum of an engine. And at a recording session, I'll put a kick drum mic on it, or I'll put an SM57 on it, and I will get it like right up against the induction tube of this thing, because it's a primary sonic characteristic of the vehicle. And then the valve train and other engine bay noises, I kind of think of this as. I kind of think of the whole car like a drum kit a little bit, where it's lots of individual instruments individual pieces that all need to sound like one instrument. So the valve train and other engine bay noises on the slide here, basically I'm just talking about kind of everything that's going on in the engine bay other than the induction. So I will take usually a pair of Rode NT5s or single point condensers, and I'll mic it up kind of like drum overheads with a basic kind of XY pattern. And I'm just trying to capture the sound of overall what's going on in the engine bay. And then the exhaust. This is the sound of gases coming out the pipe at the back of the car. And you can actually, it's going to make it hideously loud and the cops might show up, but you can actually unbolt and take the exhaust off of a lot of cars. And that instantly makes any car sound like a race car. Keep in mind that it is just ungodly loud when you do that, so you're going to want to be aware of kind of noise restrictions. And make sure that you can, and also when you do that, you're going to want to think of your microphones as well. You're going to have mics that can handle like really high SPL levels and things like that. But different mufflers and different exhaust systems can very much affect the sound of the car, obviously. And what we found out is that it's way easier to take a car that's been tuned and modified. It's way easier to take an aggressive sounding car recording and dumb it down rather than take a boring recording and try and hype it up. So for Forza, we actually quit recording stock versions of cars, and we usually only recorded modified versions of cars. And here, this is a picture of a Porsche GT3 Cup car on the dyno. This is one of the single loudest sound sources I've ever been around in my life, and this is one of the ones that got the cops called on us, even though it was in a commercially zoned area. But still, the cops showed up and they were like, what is going on here? And then we did a run for them and they were like, okay, that's awesome. And they just hung out and watched us. So this is a roller dyno. There's a couple of different ways you can kind of record cars, if you will. You can record them in neutral, where you just put them in neutral and you just kind of rev it to whatever RPM you want. For Forza, we used a dynamometer, which is kind of like rolling road, essentially, for cars, where you drive the car up on it. And you can fully engage the gears and actually drive the car like you would on a like the way you run on a treadmill. This is called a roller dyno. There's another type of dyno called a Dynapack, which is preferable actually for recordings, where it's a resistive system that bolts directly to the wheel hubs of the car. You take the tires off of the car and you bolt these resistive boxes onto it, which works really well. And then and then you can also take a car just out on the road, out on the track. Figure out ways to, put microphones up on it. But this is kind of our basic miking scheme, where, we've got, distant microphones here, close mics on our exhaust pipes up here. We would usually mic up the exhaust, pretty close with dynamic mics, and then usually a couple of feet away. So it's the drum kit analogy. Some close mics, some distant mics, but you want to make the thing all kind of sound like it's one instrument. And we would always start with a power pole, which is kind of the full horsepower, full throttle run up through a gear to make sure that the car can handle what we're about to do to it, and then B, set our levels to it, because that's usually the loudest thing you will record, and that's a straight up just full throttle run, and the dyno operator will know what you mean when you say, hey, let's do a power run. And then recording your loops at a steady pitch. We would tell the dyno operator, all right, let's go up to red line, or however high the owner was comfortable letting us take his car, usually 500 RPM below red line. And we'd hold it there for 6 or 7 seconds, and then that would be our recording. And then we'd take it back to the shop and find the best 1 second or so long loop out of that. And then that's what would be the system for Forza. And then some cars actually sound better if you back off the throttle a little bit. And there are some dynos out there where you can actually record the car at each RPM without any throttle at all, because the dyno is powered, and the dyno is spinning the car wheels rather than the car spinning the dyno wheels. And keep in mind, this approach can be used for any kind of engine. Anything that you can spin up can be recorded in this manner. So to illustrate our point here real quick, this is a blow-up of a Lamborghini Diablo. It's 12 cylinders, and it's a very aggressive-sounding car. And I don't have a laser pointer, but I'll just talk you through the process here. So this is, think of it like a mirror. Each half of the engine is a mirror image here. So this is the intake tube on a Diablo. The engine's in the back of the car. So you pull off the back cover, and you have your intake tube here. And Air comes in here. You can see we have a mic on it. We have a DPA mic, close micing it. Air comes in here, goes through the air filter here, goes here to the throttle body, which is controlled by your gas pedal. So you step on this thing, and actually it's kind of ironically named because the gas pedal is actually the air pedal. So air comes in here, and then as soon as you step on the gas pedal, this thing opens up and lets air into the engine where it gets mixed with fuel. And then these here are the exhaust ports. So air comes in here, gets blown up, and then gets shot out these exhaust ports, which make their way on out through the exhaust system and exit the pipe. And the car sounds a 12-cylinder car, and you'll notice this particular car, like each cylinder configuration kind of has its own unique characteristic to it. Like 4 and 8-cylinder cars kind of have to think of it in musical terms, kind of have a unison component. 6, 10, 12-cylinder cars have sort of a chordal component to it. This is a 12-cylinder car. Here's what it sounds like. It's kind of almost a major third musical interval to it. Now, let's go to our next thing here. Bump. Now, a vehicle is actually not just the engine, though. For cars, there are other things that go into the vehicle experience. The tires, the transmission, turbos and superchargers, those are called forced induction systems, and what those do is those blast more air into the engine that would normally be there. So they're when you hear a boosted engine, that's what they're talking about. Suspension and chassis noise of the thing. And when you start talking about ships, like planes, a plane has an engine, but it also has propellers, which are a key part of the noise generation process. All the flaps and ailerons make noise. The rudder in the back of the thing makes noise. If you're doing sound for a train, yeah, it's got an engine, but it's also got what are the primary sonic things of a train? Everybody thinks it's the if you ask somebody just from the street, hey, what does a train sound like? It's that chicka, chicka, chicka sound. That's the wheel linkage, the suspension sounds, and then the braking, and then if you're doing, kind of a steampunk type of thing, it's the steam whistle. So, yeah, it's important to note that it's not just the engine, even though the engine's a primary component. These are all things that help make it feel real. So, a quick note here about traction and tires. In a game, this is actually very, very important. We talked there was a QA thing earlier in one of in Simon's dynamic mixing talk, where we were talking about using dynamic mixing to highlight various parts of player feedback, and traction sounds are actually a key part of player feedback. Think of your tire as a pie chart having 100% of grip. And then when you exceed that, you start to lose control. And the game parameter we would use for that is this thing called slip angle, which is kind of the delta or the difference between how much you're trying to turn and then how much you're actually turning. You may have heard terms like oversteer and understeer before. Oversteer is when you've input a certain amount of turning and your car is actually turning more than that. That's, we all think of it as drifting, And then understeer, which to me is scarier, where you've input a certain amount of turning and your car is not turning that much. And if you're in real life, that is an extremely scary situation. So think of it in terms of how much, in percentages of peak grip. When I'm doing tire sounds, I start to think about it. You've got a tire starts to sort of howl, or you get this kind of scrubbing sound that happens as you approach 100% of peak grip, and then it starts to screech once you go past the peak grip. And then the more you get past that, the more intense that screech gets. So you kind of get it'll start to scream at you, but at first it'll go and then it'll start to develop into a howl, and then it'll start to develop into a screech. And tire audio is a key part of players knowing where the edge of grip with their car is. And also then an important note is that load, whenever you turn and you start to squeal your tires, your car is actually leaning to that side, and so that load will sort of push the pitch of the tire down. So that's why you get that, when you come out of a skid. Now, let's talk about imaginary vehicles for just a moment. When doing sound for an imaginary vehicle, I always like to kind of think of what's sort of the basic sort of genre approach. Do you want to do it realistic, or are you going for like a straight up sci-fi kind of thing? The whole Batman versus Star Wars thing, where Batman has some sort of basis in the real world, but those are still imaginary vehicles, versus Star Wars, where it could be, hey, let's do a lion in a vacuum and see what that sounds like. And then I always like to design purely offline audio targets so I can help sell my audio vision to non-audio people, which anybody who's worked on an embedded team before will know that that's a key part of the process, is being able to convince designers and producers that what you're doing is actually awesome. So make something awesome, play it for them, and then figure out how to dissect it. And then once you've got it kind of dissected, once you've got it sold, I should say, then figure out how to sort of chop it up. You can have sustained versus one-shot sounds. A good idea for me in stumbling across certain things was that getting away from the idea of that things don't always need to be pitch-based to, there doesn't always need to be a pitch to intensity ratio. You can use, unpitched audio intensity for a layer, like, filtering white noise for like, as you go faster. For a train, frequency doesn't necessarily mean pitch. Frequency is instead the sound of the wheel linkage. It's just a chick sample. Frequency is just rate of playback in that case. And then for very simple systems where you just have like mostly binary systems where you just sort of have an on-off type thing, think about using a shepherd tone. And a shepherd tone is kind of an audio, for anybody that doesn't know what that is, it's kind of an audio illusion where it's either a tone that's perceived as always rising or always falling. Kind of the way they do it is they'll set a sound going up, and then they'll start to sneak in the bottom octave under that and gradually fade out the top octave till the bottom octave takes over. And so it's just kind of this illusion of something either always rising or falling. And so that's very effective for systems where the only physics system you have is either go or stop. And in some cases you can also, and I'll talk about Fakery here, where you can, it's a good way of doing sort of, think of it like perpetual motion. You can have a shepherd's tone doing that. You can have an endless gearbox that does that. In terms of my car doesn't have 5 gears, maybe it has 50, or until I stop the car, It's just this idea of making the car always sound like it's in motion so that you don't have a game where as soon as you get on full throttle, the car just sounds like whee for as long as you've got the thing pinned. And then these are common like audio, basically, systems that only exist for audio. They're physics-based systems, but they only feed the audio system. When I talk about using a spring mechanic here, think about it like instability, like when you shift. In a race car usually doesn't just go wee, bream, bream. It goes wom, like that. Which kind of helps, gives the illusion of strain and power being exercised. RPM variance or redline, you get the thing up so it doesn't just go, goes, you kind of vary it, you vary the timbre of it to make it sound like it's straining, give it some sort of motion so it's not just a static state. Idle and redline RPM offsets, middleware still thinks that cars idle at 0 RPM. When they don't, they idle at like 800 or 900 RPM, and as soon as you try to pitch a loop all the way up from 0, if you put in an idle loop and you try to pitch it from 0 RPM to 800 RPM, it's actual idle, it sounds awful and terrible. And then so you can have some sort of offset system to where you can say, okay, my car will idle at 700 RPM, and it'll automatically tune that. Or, and what we did for Forza was also have a redline RPM. So if I've recorded a car that sounds really great, but my recording only goes up to 6,000 RPM, but in game the car goes up to 9,000 RPM. I'm not going to be able to stretch that top loop very far without it sounding like a spaceship. So I will put in an RPM, an audio-only RPM of like, 6,600 or whatever. I'll figure out how far I could stretch that, and then I'll make that the idle offset, the RPM offset. A shift time offset, if your car shifts slowly, a race car that shifts really slowly sort of breaks the illusion. Doesn't sound right. You want the you know, you want a really fast shift with that sort of stuff. And then the endless gearbox. And then the last slide here, sorry, I'm blasting through this stuff. Just a quick note on mixing. We heard we heard Simon talking about that earlier today. Think about the dynamic range of your car. What do you want it to be? You have an on-throttle volume versus an off-throttle volume. Some games like a really distinct sort of, they want a good, 10 to 12 dB jump when you get on the throttle. Other games just want a big timbre change, not necessarily a volume change when you get on the throttle. Camera perspectives when you're mixing. Do you want your car to purely be driven off of a balance of just very, very carefully placed 3D emitters and you have to place them very carefully so that when you go into chase cam versus cockpit cam, everything still sounds appropriate. You can still hear everything sounding. Or if you get into a certain camera view, sometimes it's easier actually just to go with a straight up 2D mix, where you say, all right, I'm going to send this much engine to the front and this much exhaust to the rear, and you set up a surround 2D mix that is sometimes can be very effective. Occlusions for cockpits, your car is going to sound different whether it's a convertible or not, for lack of a better term. So come up with some kind of an interesting filter, not just necessarily a low-pass filter, but more of a more complex filter than that. Fall-offs and radii. If you're in a racing game especially, you need to set these up differently for racing versus replay. You want to hear cars when they're kind of coming up right on top of you, so you might set your fall-offs for that, so that when the AI cars are approaching, you can hear them really clearly. But that fall-off might sound really weird if you've got a replay camera that's set way down a straightaway and a car is coming from, a long way away, but you hear it like it's really close. That can really break it for you. And then another common problem with replay systems is that game designers love to put cameras a billion yards away and then zoom them all the way in. And that can be really tricky to get around as well. So having kind of custom fall-offs and radii for replay versus racing is key too. And then talking about dynamic mixing again. How many vehicles do you really need to hear at any one time? And what's the most important part of your racing experience? A lot of racing games, play the nearest 6 or 7 cars to you, even though there might be 20 cars on track, just because the mix is so cluttered at that point. That you just want to sort out what are the kind of the key parts of that experience. So it's kind of about managing your mix and then figuring out, and also taking into account voice count and things like that. It's less so with the current gen of stuff, but what really do you need to hear at any one time to make it seem effective? And I think with that, is that our half hour? How are we doing on time? Did we make it? Okay. Sorry, I went a little tiny bit over, but I think we made it. At that point, let's take some questions. I feel like I should sit in one of the chairs now. We're all friends here. Go ahead.
You talked about 3 types of sounds for vehicles, loops-based sounds,
Right.
amalgam, and synthesis. Can you merge the 3 different systems together to get the best value from?
That would kind of be the holy grail if we could figure that out. I don't know if anybody's really figured that out yet. There are definitely some hybrid systems out there that kind of use, each system kind of has its own strengths and weaknesses. I think the perfect system would actually be a system that would maybe use all 3 and then switch between them depending on the behavior of your car. For a loop-based system, like the easiest way to break a loop-based system or to expose a loop-based system's weaknesses is just to sit at the starting line and rev the car, whereas that's where a granular system sounds really great. Where a loop-based system really excels is in like a long straightaway, where you're very slowly progressing through RPMs, and that's where kind of granular systems sometimes fall down a little bit. But granular systems sound really great if it's more of an arcadey kind of thing, where it's your throttle's on, off, on, off, on, off a lot of the time, and you're not doing a lot of like gentle feathering of the throttle. So I fully believe that there's a hybrid system waiting to be made that combines all this stuff into sort of one flawless package. I don't think we've hit the holy grail of it yet, by any stretch.
I know that for the low ends of the cars, I usually use just a small
Right.
then ditch that. But if you can have the synthesis just for the low end and the card, that would be great.
Yeah.
Also, for example, for the idle, I think that the best solution would be Loop because it's the real sound of idle sound. So maybe limiting.
Yeah. Well, think of it. You have to be able, and also the thing with synthesis-based stuff is you'd have to have, like, getting the actual instability right to be a realistic sort of instability would be really tricky. You know, think of the way a Harley idles. You know, it's really lopey. It's kind of got this crazy instability to it, but a really recognizable sort of instability. To try and duplicate that with a purely synthetic thing would probably be tough, but I'm sure it could be done at a certain point. I mean, I think we're going to come into you know, now that we've got so much power in the current generation of stuff, I think we're going to come into some systems that are, you know, a truly hybrid thing like you're talking about, and then it's going to get real hard to tell what's real and what's fake. Yeah.
With granular synthesis, is it dependent on what you're trying to reproduce? Like my real question is the length of the bits.
The length of the grains, right. A lot of it is just tuning, and also granular systems in particular react very differently to the type of content that they're fed, the type of recording. Like if you have a very aggressive recording, you have to pick, basically it gets down to sort of picking firing cycles, like actually looking at the recording and seeing where each sort of pulse is of the, you know, if you have a 12-cylinder engine, you know, looking for the 12 bar, you know, looking for the 12th one and making that your grain. You know, or, you know, there are some systems where if you wanted to, you could actually go in and take one pulse and just make each pulse its own grain and then just rearrange them in a firing or in the same firing order that the manufacturer has done. You know, you can get really down to the nitty-gritty with it, but at the end of the day, it's all about sort of what it sounds like. And I know it's a different way of thinking about it for sure, but you know, every racing game kind of has their own strengths and weaknesses, and they're just, you know, like I said, I think everybody's still kind of looking for the perfect system, and you can really tailor it to the type of game that you're making too. Anybody else? All right. Well, thanks, guys. This was fun. I appreciate it.